Alright, it's time for the solutions for the exponential function parameters assignment here. Each of these you got a situation you read through, and it's going to ask you a couple questions about it. A lot of these, they give you a function. A couple things to remember: the number not with the exponent, the number not in parentheses, is your starting amount, that's your initial value. And then the number inside the parentheses, that's what you're multiplying by every time. And that'll come into play as we answer different questions about things. Okay, so first question about this one: what is the starting amount of rabbits? Well, that's the number right there. It's going to be 52. What does the 2 represent in the context of this problem? We have to read the problem before, but that represents the doubling of the rabbits each hour. Not each hour. Was that each week? Oh, each month. Each month. I'll probably just pause as I write down things like that in the future. Okay, number 2, the amount of money that Kate has in her I should really go to college account. The starting amount of money is the number not with the exponent there. It's going to be 2,500. And this one's asking about percent growth. If you ever wonder percent growth, percent decay, take that number and convert it to a percent. If you ever want to do that, you just take whatever the number is times by 100, and it'll turn it into a percent for you. So this is 106%, which is not the percent growth. Your percent growth is going to be how much bigger that is than 100%, because if you take a number and you times by 100%, that's like times by 1, doesn't do anything. But when you times by 106%, or 1.06, it's going to make it bigger. So that extra 6% is what's the growth rate. Moving on to problem 3. This one's asking about the decay rate, and that's really simple. It's like a percent of decay. You're going to start right here with this guy here. That has a 98%. So that's kind of what you're timesing by every time. Well, what is that? Less than 100%. Well, if you take 100% and subtract the 98, that's going to give you 2%. That is the decay rate. That's what percent is lost each year. Next part, what does the 42 in the function represent? Well, if you read this first part, the 42 chunk of uranium, that's the starting amount of uranium. Moving on to 4, this one's about the spreading of the Ebola virus. We can model how many people are infected with that. The 1 in this case is our initial value. That's how many people start with Ebola, just 1. And the 2 in this one is representing a doubling effect. So each week, the number of people with Ebola is going to double. So let me write that up. Okay, so there you go. I rephrased the second one. The number of infected is going to double each week. So that's what's happening with the 2 extra. Problem 5. Nate found that 4 fruities wasn't enough, so he's just picking out, eating a lot of them. So the 3 in this case would be timesing by 3 every second, which is kind of triple the number of fruities that he's eating each second. And then the 4 represents his initial amount that he ate in the first second. So let me write those down. So I wrote that out for you. Moving on to the next one, number 6 here. So temperature, so here's delectable hot chocolate every 15 minutes. It's given by that. What's the starting temperature? Well, that's your initial value. That's going to be right there. That's going to be 98 degrees. What's the percent of decay? Well, this right here is not a percent as it sits right now. But if you do 4 divided by 5, you're going to get 0.8, which when you convert to a decimal, a percent, it's going to give you 80%. So it's keeping 80% of the amount of heat. So if you take that number and you subtract that from 100, you're left with 20%. And that's what percent gets lost each 15 minutes. So it's losing 20%. That's the percent of decay. On problem 7, Frederick Claudio Francis Smith III. He's raising chickens. You get this function describing how many chickens there are. The x in this case, you have to look really closely at this last sentence. for something that it can stand for. It can stand for number of chickens, or it could stand for the yearly, like how many years, because it is a yearly total. And in this case, it stands for the year, like number of years. And the 32 in this problem is going to represent the starting amount of chickens. Right, so there you go, 32 chickens to start with. Problem 8, Professor Evil filling in this silo with sludge to poison all the wells. So right here it says if it takes 5 minutes to fill the silo, how tall is it? Well, this 5 minutes, you're either going to put it there or you're going to put it there. And in this case, the x is a time limit, and s of x is a height. So you're not going to put 5 in for s of x, you're going to put it right there where the x is. So if you do 2.75 times 1.9 to the 5th power, and you plug that in, you're going to get approximately 68.09, and that's in feet. So you can get that. The height of the sledge when x is 0, well, you just take this and you put a 0 in for the x part. 2.75 times 1.9 to the 0 power. Well, anything to the 0 power is going to be 1, so this part is just going to be 1. And so really you just have 2.75, and that's in feet. Moving on to 9, Topher runs up a huge credit card debt, okay. And we get this function here, the amount of money he has. Okay, so the amount of money that he has, that he owes, is going to grow if he doesn't do anything. Why is the function negative? Well, that's because this debt, you can think of it as negative money. You actually don't have that money. So yeah, that's why we'd have it be negative. And what's the percent rate of his debt? Well, right here, you need to convert that to a percent, which is 123%. That's not like the percentage rate. You need to actually subtract out the 100 part of that, and that's going to give you 23%, like APR. So annual percentage rate is typically what those interest rates are. And let me write the other answer down. Right, yeah, so it's negative because he owes that money. He's not going to have that money. He's out that much money. Moving on to problem 10, we have Miss Novak here, starting giving Fs at an alarming rate here. How many Fs did you give on the first day? Well, the initial value is going to be right there. So you have that be your initial value. You could also argue that day 1 would be what goes in for the x there. So you have 4 times 1.5 to the 1st power. And when you do that, 4 times 1.5 is going to be 6. So that would be how much she gave on the first day, on a given day, the day 1. And then the growth rate for her Fs, well, this here is dealing with your growth rate. Convert that to a percent, that's 150% times by 100, and you subtract out the 100 piece of it because you're not adding 100%, you're timesing by the 100%, and so that really doesn't change your number. The extra 50% does. So that one comes out to be 50%. Number 11, contestants in a tournament here was 128%. I mean, 128 stand for. That's your initial value. That's the starting number of contestants. Alright, so that's the starting number of contestants right there. And the next question is asking whether it's single elimination or double elimination. Well, if you do one round, you're going to put a 1 there, and you're going to have to do 1/2 to the 1st power, which is 1/2, and times it by 68. So after one round, you're going to have 64 contestants. So if you have a double elimination tournament, you have to lose twice to get out. In this case, after one round, we lost half the people. That means it's going to be a single elimination, because if you lose half your people in the first round, they would have to everyone could only lose once in one round. Alright, problem 12, Judith bought an awesome computer. The first question is how much did he pay? That'd be the starting amount here, which is going to be $3,200. And what is the depreciation rate? As in the decay rate? Well, you have to take this guy, convert it to a decimal, which is 75%. and that's how much you're keeping. The part that gets lost is that subtracted from 100%, which is going to be 25%. Moving on to 13, we have food company. The value of the company is growing rather quickly. It's asking what the percent growth is. You're going to take that, convert it to a percent, which is 175. But you need to subtract 100%, because the 100 part is kind of the base amount. The extra 75% is what's making it grow. So you're looking at a growth rate of 75%. What's the starting value of the company? Well, that's right here, the initial value. That's going to be $23,000. Problem 14. New school opens up, gets a bunch of students. What's the starting amount of students at the school? Well, that's if that is 0, as in no years have passed. So we're going to have that be 0. It makes this 1. So really we got 450 times 1 plus 300. That's going to give us 750 students. What could the 300 possibly represent? And this, I kind of threw this in just so people would kind of think about how, like, why would you have some base amount there, and you can have that just be the least amount of students it goes down to. Right. So that's kind of like the lowest amount of students, because when this gets really small and you times by 450, you're going to get pretty much 0 there. But the extra 300, I mean, there's still 300 students there, and that also plays a role as an asymptote, if you remember anything about asymptotes. Number 5. So we got this town. We built a town at the base of an active volcanoville, and they lived for a while. And then they decide we should probably leave because it's active volcano. It's acting up. And so on this one, we need to write a function. Let's have p be my main variable, as in the population in the town. It started out at 2,600 people, and there's about 60% that are able to leave each hour. So the amount that's going to stay, that's 60%, that's your decay rate. The percent that stays is going to be 40, and you have to do that to the x power. So that's where those pieces come from. Initial value, the amount that's staying after each hour, which is 40%. And we move to problem 16. You have your air, your lungs full of this gross air, but inside you got some filters going, kind of cleaning out your lungs. So let's say this is the amount of smoggy air, so we'll have that be S. So S of X, the amount of smoggy air, or that's 500 milliliters to start with, and you're replacing about 12% of the air in the lungs. So that is not the amount that you're keeping each time, that's the amount that you're losing. So if you take the 100, you subtract out that 12, you're looking at 88% that's staying each time you take a breath. And so we're looking at a function like this, where you keep 88% each breath. Moving on to 17, you get 10,000, but you're going to put 9,000 into a bank account. Let's have A be the amount in our account, and we'll have X be the amount of years. And so our starting amount in the account is 9,000, and we need to do 4%. Which is our growth rate. You need to have 4% more than 100%. So you're going to have 1.04%. And you're going to have that to the x power. That's the number of years there. So that gives us our function here. You increase by 4% every times by 1.04. Moving on to 18. So Trivia Crack has become quite popular. It's growing really fast, but right at the beginning it wasn't very popular. Someone had to start playing it. So this one started at about 400. Let's say P, as in the amount of people playing the game, is going to be what the P stands for. It started out at 400, and this one is doubling each week. So we're going to times by 2 each week. X is going to represent the number of weeks. So it's just going to be 2 to the x power. On 19, Bobby's getting flu, goes to school anyway. We're going to have I be the name of this function to stand for the inflicted. And at the beginning, there's only one person sick, but each person's getting 3 other people sick. So you have to times by 3 each day. So next day, you're going to get 4. There's going to be 4 people sick total. But each of them is going to get 3 people. So you're like just times it by 3 each day to get your total amount of sick people. And then Dylan's Vine is getting rather popular rather quickly. Let's have let's have L be the number of likes. I'm going to have that be L of X. And the starting amount of likes is going to be 20. And we're going to assume it's doubling each hour. So we're going to times by 2 each hour. It's going to be 2 to the X right there. And that's going to be our answers.